Hello everyone. In this video we're going to be simplifying a radical expression. We have 1 over square root of 5 plus 2 plus 1 over 2 plus square root of 3. I'll be presenting 3 methods, but I'm not going to work out the second one because that's kind of time consuming. Alright, let's start with the first method. So my first method involves making a common denominator. If you multiply the first one by 2 plus root 3 and the second one by root 5 plus 2, you're going to get the following. And the bottom is just going to be the product of the denominators. If you simplify the numerator, that's going to give you 4 plus root 3 plus root 5 divided by the product, root 5 plus 2 and 2 plus root 3. Let's go ahead and distribute it. 2 root 5 plus root 15 plus 2 times 2 is just 4, and then plus 2 root 3. Great. So we got a radical expression which is kind of hard to simplify, and if we go ahead and put it like this, 4 plus root 3 plus root 5 divided by, I'm going to write the integer first, which is 4, and then the 2 root 3, and then the 2 root 5, and finally root 15. Now, this is a radical expression, and I'm hoping that that can be simplified and turned into a similar radical expression, which contains the following: a plus b root 3 plus c root 5 plus d root 15. Now here, a, b, c, d are rational numbers, and they can also be 0. So we're going to do the following. Next, we're going to cross multiply and set the product equal to this. And then from there, we're going to get something like this. For example, if you multiply 4 times a, you get 4a, which is going to be rational, if a is rational. Then if you multiply 2 root 3 by b root 3, that's going to be 6b, another rational number. If you multiply 2 root 5 by c root 5, that's going to give you 10c, right? And then if you multiply root 15 by d root 15, you're going to get 15d. So those are all rational numbers. Their sum is also rational, and that is going to equal the rational number in the numerator, which is 4. So that kind of gives us a system, and the other ones, without further ado, I'm just going to give you what the other systems are, and they're going to come from this product. For example, if you multiply 4 by b root 3, that's going to give you 4b as the coefficient of root 3, and then 2 root 3 multiplied by a is going to give you 2a root 3, which is another coefficient. So by putting all these together, you're going to get 2a plus 4b plus 5c plus 10d equals the coefficient of root 3 in the numerator, which is 1. Then 2a plus 3b plus 4c plus 6d equals 1, again the coefficient of root 5. And finally, a plus 2b, or not 2b, plus 2c plus 4d equals 0, which is the coefficient of root 15. Notice that we don't have root 15 here in the numerator, therefore its coefficient needs to be 0 from the cross product. Okay? So this gives us a nice system. Just kidding, it's not nice at all. But using matrices or other methods, you can solve it. It's a linear system in 4 variables. And let me tell you what the answers are. A and d are both 0, b is -1, and c is 1. If you plug these in, you're going to notice that they satisfy the system, of course. So this gives us the following. Since we've found the values of a, b, c, d, now we can write our expression in a simpler way. Remember, our expression was written as a plus b root 3 plus c root 5 plus d root 15. Now a and d are both 0, so we're not going to write them. b is -1 and c is +1. Therefore, this expression can be written as root 5 minus root 3, which is the simplified form of this expression. It's kind of hard to believe looking at the expression, which looks complicated, but that's basically what it is. And the third method is going to make it actually more clear why we get this answer. All right, the second method, which is this one that I'm not going to work out, is after making a common denominator, remember the expression that we got something like this, right? And then we can basically take that expression, 4 plus root 3 plus root 5 over 4 plus 2 root 3 plus 2 root 5 plus root 15, and just rationalize the denominator. You can find the conjugate, like kind of group these two terms together, and then find the conjugate. Keep doing this until you get no more radicals at the bottom. All right, but that's time consuming. Let's go ahead and take a look at the third method. So our third method involves the following. We're going to go ahead and let me rewrite the original expression. It was 1 over root 5 plus 2 plus 1 over 2 plus root 3, right? That was the expression we were trying to simplify. Now with the third method, here's what we're going to do. Why not just multiply by conjugates, right? And I know some of you, maybe all of you, were thinking about this when as soon as you saw the problem. That's going to be root 5 minus 2 here and 2 minus root 3 here. But we're going to multiply them by ones. So they're going to be like this. Root 5 minus 2 over 5 minus 4. And the second one is going to be 2 minus root 3 divided by 4 minus 3 from difference of two squares. But both of these are equal to 1. So this is going to give us for root 5 minus 2, right? Plus 2 minus root 3. The 2's are going to cancel out, leaving us with root 5 minus root 3 as the simplest form of this expression. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.